Greetings, this is this, and I am me. And I know what you're thinking. I can't write this circle without memorizing it. I just have to memorize it. It's too complicated. But guess what? You can. If you're here, it's because when you see the diagram, this diagram when it's completed, you think, what is happening? That's too complicated. That's an explosion of something. I'm just going to memorize the whole thing. It's going to take me forever, but I'll do it because it makes no sense. Guys, really all you need to know is one thing, okay? One thing. But okay, just that's all, okay? And it's how many degrees are in a circle. So if you don't know that, I'm telling you right now it's 360. Okay? And so as long as you memorize that, you can draw the whole rest of the circle. The reason it looks so complicated is because they just pile on like 15 different diagrams in one circle. And so it's hard to make sense of it all. And a lot of the times it's not explained. They just give you the sheet of paper and they're like, here, this you need to know. But guys, it's simple, okay? So if you know that a circle has 360 degrees, and this is just kind of the regular place to do this beginning thing. So that's why I drew that in already. If you know a circle has 360 degrees, then you can divide that circle in half and know that this side is 180, correct? Okay, good, cool. Then, knowing that, we could put the other lines, actually, you know what, let's do that. Why not? So I'm going to draw these next ones in green, I suppose. Because really what you're doing here is you need to divide the circle into 30-degree segments and 45-degree segments. That's really all that the diagram is. Technically, there's also 60-degree segments drawn in, but they get drawn in when you draw in the 30-degree segments, so you don't really have to worry about that one. Because those are the three different types of triangles, is 30-degree, 60-degree, and 45-degree. That like you'd be working with later. So, to start, if you knew 360, you figured out the half of a circle. So I've divided it into two halves. So think of it as a distance. To travel this distance, it's 180 degrees, because then to travel all the way around the whole time, it's 360. Okay? So if we know that traveling this distance is 180, we also know that traveling this distance is 90. And you're like, well, yeah, I knew that one already, too. That one's pretty easy. And I'll put this one down here also just because y'all probably are already screaming at me saying, you know that one, too. Okay. So, but if you didn't know this one, you know now that this distance, 1/4 of the circle is 90. And so we can just go from here plus 90 is going to get us to 270, okay? And then you can double check always to see, oh, if I add another 90 chunk, will I get 360? You will. Okay, but now we've made it really easy to find our first 45-degree chunk, because half of 90 is 45, okay? So there you've got 45 degrees. And like I said, we need to divide it up into 45-degree chunks. So just literally go around, guys. That first one, 45. Add 45, you get to 90. Add 45 again, well, bam, you're going to get right there to 130, a 5. Add 45 again, you get to 180. You can double check that. That's, a good way to double check yourself. And then also, you'll see that you've divided this first half into 4 parts. So technically, whatever you do on the top half, you can just automatically, boom, do on the bottom half. Make your life that much quicker because it's going to be symmetrical. But if you didn't want to do that, and you wanted to be careful, cautious, you could just keep going. So I added 45 and I got to here. If I add 45 again, I'm going to get to what, 225? 225? Yeah. Then 270, we're going to move 45 degrees over again. And we get to, what, 315? Yes. 315, okay? And then add 5 would get us to 320, plus 40 would get us to 360. Then we're done. That's the 45s right there. And what I mean by that, guys, is like this distance right here is 45 degrees, and then that distance and that, you know, keep going around in 45-degree chunks. I'm going to erase that though because I want to draw something else that's going to get in the way of that. So now your circle's pretty much halfway done, okay? Now I'll take the blue because we're going to be doing 30-degree chunks now. And this, I mean, sure, you can guesstimate where the first 30 is going to be, right? Because you know it's less than this 45 here. But that might be a little bit complicated or a little bit overwhelming. Think of it this way. If I have to make it in 30-degree chunks, and I know that there's 60 degrees total, I can just say, okay, so how many 30s fit into 360? Which is really just cross off the zeros. How many 30s, how many 3s fit into 36? Which is an easy, not an easy problem, that's not the word I want, calculation, an easy calculation to do. It's 12, right? So you're going to want this to be cut up into 12 30-degree chunks, which is hard to see when all of the lines are black and they all look the same, which is how they usually look on a diagram. So I'm drawing them in blue so y'all can see the difference. But so 12 equal-sized chunks, you still might be overwhelmed. So how about this? If you know you have to have 12 chunks in the whole thing, then you know you're going to have 6 on the top half and 6 on the bottom half. So can you divide this top half into 6 pieces, 6 even pieces? Okay, if that's too complicated, can you divide a quarter into 3 pieces? Because this whole top half, has to be divided into 6 chunks, which means that half of the top half has to be divided into 3 chunks, which is something like that, okay? So we're going from here to here. This is 1 chunk. And then here to here is a second chunk. And then from here to here, I'm going to put that in blue also so we know it's for both. From here to here is that last chunk, right? And so we know that this first one was 30. And then the next one is 60 because we're just adding 30 now. And then the next one is 90. Okay? And so this is what each quadrant is going to look like for the blues. You're just going to have 2 segments like that are going by 30s. So if we got to 60 here, and to 90 here, that means we're at 120 over here. And you can always double check that it makes sense. The 135 is after the 120, so we're doing good. And then 120 plus 30 is going to get us to 150. And then double check that 150 and 30 gets us to 180. Good. And then just do the same thing on the bottom. And so 180 plus 30 is 210. Then we go to the 225 is after that, so that's good on my part. Then we have 240. And then add 30 again, you're at 270. So we're doing good. Everything's right on track. And then you divide up your last segment into 1, 2, 3, more chunks of 30. 270 plus 30 is 300. 300 plus 30 is 330. 330 plus 30 is 360. Boom, guys, you did it. So that's all of your lines, right? And all of your degree measures. And you're like, that's all well and good, but I still have to do the radians. How do I do the radians? Those are complicated. No, guys, it's not. Because once again, you only need to know one thing. Just like you needed to know 360 degrees in a whole circle. You need to know how many radian degrees, radian measures, whatever, in a whole circle. And that is 2 pi. Okay? One whole travel around the circle is 2 pi. And knowing that, we're gonna figure out all the rest, okay? So, if 2 pi is the whole circle, once again, we'll go the same way we did last time and know that half of the circle then is pi. Good. And then we can also figure out if half of it is pi, then half of that is pi over 2. Because, it's half of pi. But if we know that right here we have pi over 2, And this 45 degree is half of that. So half of a half. If you wanted to take this and divide by 2, you would do that by bloop, 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 multiplying by a half. And when you multiply a half, you do the top over the bottom, right? I'm sorry, that's off screen. See? So pi over 4. This one right here is pi over 4 because it's half of what this one was. See this? If I want to travel this distance, it's pi over 2. So if I want to travel half of that distance, it's going to be pi over 4. And then we've made it super simple, guys. Because now we know that 1/45 distance is equal to pi over 4. And you can also remember that 45 goes with the 4, okay? Once you know that, you can do all the 45 measurements. So we have pi over 4. And so then if we go another one, we have 2 pi over 4. Because we have 2 pi over 4s, you know? So this is 2 pi over 4, but that reduces. Then just go to the next one. This is going to be 3 pi over 4. Okay, and then this one will be 4 pi over 4, which reduces. So this is 5 pi over 4. And this is 6 pi over 4, but it reduces. And so then this is 7 pi over 4. And then obviously that one is 8 pi over 4, which also reduces. Pi over 4 is done. Okay, I don't even know what color this marker is trying to be. It used to be like a purpley color, but just please excuse it. But we're going to move on to the radian measures for 30-degree chunks, okay? So, what we figured out here when we drew the 30-degree chunks is that there was 1, 2, 3, 4, 5, 6 in 1 pi. So we divided pi up into 6 parts. That means each part is 1/6 of pi, right? And so if this first chunk is pi over 6, then the next one is 2 pi over 6, which reduces to pi over 3, okay? And so that's a thing that you can remember if you want to, but you don't need to, is that the pi over 6 goes with the 30 degrees, and the pi over 3 goes with the 60 degrees. It's opposite, okay? Because, well, yeah, with the 60 degrees, you can see there's 3 in 1 pi, because we have this first chunk right here, and then we have that one, and then that one. But anyway, like I said, that just draws itself. You don't need to worry about that. So just do the same thing you did with the pi over 4s, but going from each blue line, okay, in chunks of 30, or also pi over 6s. So pi over 6, 2 pi over 6, 3 pi over 6 reduces. 4 pi over 6 is going to reduce to 2 pi over 3. And if you don't like to have to do the reducing like that, you can always just go by the 60s. And so you'd have pi over 3, and then to the next chunk of 60, you have 2 pi over 3. See how that makes sense? Okay, but anyway, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6 reduces, 7 pi over 6. 8 pi over 6 is going to reduce to 4 pi over 3. Sorry if that's a little cut off. 5 pi, no, sorry. 7, this was 7 pi over 6, this is 8 pi over 6. 9 pi over 6 reduces. Oh, I never put that down there. Never put that measurement. 3 pi over 2 is what it says down there. 3 pi over 2, okay? So where were we? If you lose your place, just go back to one of the non-reduced ones. 7 pi over 6, 8 pi over 6, 9 pi over 6. This is going to be 10 pi over 6, which is going to reduce to 5 pi over 3. Then we move on to 11 pi over 6. And then the last one would be 12 pi over 6, which reduces to 2 pi, which makes sense. You did it, guys. That's the whole thing. So instead of having to try to memorize every single one of these lines and every single one of these degree measures and every single one of these radian measures, you can literally just use these 2 pieces of knowledge and then map out the whole thing yourself systematically. It might take a little bit longer, when you're actually doing it, but you don't have to take all the time to memorize how to do it. And then the last thing I will talk about is if you need this to be in a number form without pi there, basically just do this. We know that pi is 3.14, okay? Therefore, you know that 2 pi is 6.28 because you just added it or multiplied by 2, whichever. That's easy. And then you can also figure out half because half of 3 is 1.5, 1.5. And then half of 0.14 is going to be 0.07 because it's like 14 and 7, okay? So 1.5 plus 0.07 is 1.57, right? That's easy enough to figure out. If you need to write it down as you're doing it, that's fine. And then you figured out that each one of these size chunks, this distance to travel, or that distance, or this distance, is 1.57. So we can just go straight from here, the 3.14, plus 1.57, and you'll get 4.71, maybe, if I did my math right. Yeah, that's how you get those numbers there if you'd like them. And I don't really think they're going to be asking you too much about all of these measurements in this sort of form. But if they do, you'd have to do the division. You'd have to take 3.14 divided by 3, that sort of thing. But that's how you do it. Sorry if that took kind of a long time. I was just trying to explain it well. I hope it helped. Thank you guys so much for watching. Bye-bye now.